you guys? This video is part 2 about MCE, Math Common Errors, dealing with exponents. In this video, I will present 6 errors many students they do and how to avoid them. You can also see other parts. There's part 1 dealing with radicals, part 2, this is the video part 2. You can see part 3 about factoring and equations. You can see part 4 in my channel Math C and T, coefficients and terms. I will also present in this video 3 examples with detailed solution so that you can avoid these kind of errors, and I will put at the end 3 practice questions with only the answers. Let's start. This is number 1. I think this math common error is number 1 between students. Look at the error here. Just read it. A plus B all squared. A squared plus B squared. So easy to write, but completely wrong, unfortunately. The correct formula, A plus B squared is equal A squared plus 2AB plus B squared. Students, they forget this middle term, 2AB. So everyone using math, if you have this formula, A plus B squared, you have to write the middle term, plus 2AB. And then you write B squared for sure, and then A squared. So missing the middle term is the big error here. Also, look that this is another error here we can say, but it's the same idea. A plus B all cubed. You cannot write A cubed plus B cubed. A plus B power 4. You cannot write A power 4 plus B power 4, and so on. Now, each one of these has a formula. Some of these formulas are a little long and big. You cannot memorize. Okay, now to find the correct formula, either you have 2 ways to do this. Either you can expand. Expand means you multiply the brackets, A plus B times A plus B squared times A plus B squared, whatever the power. Or you can use Pascal's triangle. So I put this information on the next slide. You can use Pascal triangles. It will help you to find the coefficients. Okay, Pascal's triangle, it's a nice triangle. It starts with 1 here, and then put 1 and 1. So when you add 1 and 1, you get 2. You see that one? So here we have 1, 2, 1. These are 1 to 1. These are the coefficients. See 1 here in the x, A squared, 2, and then another 1. So 1, 2, 1. These are the coefficients when we have power 2. Now, if you add 1 and 2, 3. 2 and 1, 3. So we have here 4 terms, 1, 3, 3, 1. So this is for the cube. 1, see the coefficient is 1, the coefficient is 3, the coefficient 3, and then 1. So when you expand A plus B cubed, you can try it yourself. You can multiply A plus B times A plus B times A plus B, or you can multiply A plus B squared, which we know this formula, times the bracket A plus B. You will get A cubed plus 3A squared B plus 3AB squared plus B cubed, and so on. So you can get power 2, power 3, power 4, power 5, until power n. Now another error. A minus B squared. Unfortunately, you cannot write A squared minus B squared. Big mistake. So what's missing? You know the story now. Missing the middle term with the minus, because if you have a minus between them, the middle term is a minus, minus 2AB. And remember, always you have plus B squared on this last term. Even if you have minus b, a minus b all squared, it will be the last one plus b squared. You can also, this one is wrong. A minus b cubed, a cubed minus b cubed, completely wrong. A minus b to the power 4, a to the power 4 minus b to the power 4, completely wrong. The solution, you can either expand or use Pascal's triangle with alternating signs. So you can put minus b inside, put a plus b. Easy to do that. Number 3, a plus b all to the power minus 1. Many math users, they write a to the minus 1 plus b to the minus 1. Completely wrong, unfortunately. So what is the correct method? A plus b to the power minus 1, all to the power minus 1, 1 over a plus b. That's the correct one. So you have to add the numbers in the denominator. You cannot write 1 over a plus 1 over b. You'll see many examples now. Also, all these formulas, you see all these formulas where we have pluses and minuses, all of them, you cannot distribute a plus b to the power minus 2, a to the minus 2 plus b to the minus 2. No way. A minus b all to the minus 2, you cannot distribute. A minus b to the power minus 1, you cannot distribute. All wrong. Now, if you have a squared like this, a plus b to the power minus 2, 1 over a plus b squared. And we know this formula before, so we write 1 over a squared plus 2ab plus b squared in the denominator. That's the correct one. Let's see number 4. So tricky. Minus 5 to the power 2. Many students or math users, they write plus 25. I have seen hundreds of people. Plus 25, completely wrong. And somebody will say, they will argue, why? Because it's wrong. Why it's wrong? There is no bracket. There is no bracket around the minus 5. In this question here, the base, you know, we have base and power, base and power, base and power. So here, look here, details, look at the details. Minus 5 squared. So there is a minus 1 times the 5 squared. So here we say what I said, base and power. The base is 5 and the power is 2. 5 times 5, 25. With the minus becomes minus 25. That's the correct answer here. But if we have brackets, minus 5, you see the way we read this, minus 5 all squared. Even if you don't see, you just hear it, minus 5 all squared. So minus 5 times minus 5 plus 25, this one here with the bracket. Minus 3 to the power 4, is this plus 81? No. Why? Math common error, there is no bracket. This is math common error number 5. I have seen this in many math users and math students. 3 to the power minus 1, they write minus 3, which is completely wrong. 3 to the power minus 1, 1 over 3. If you have a power in the negative, you should convert it to fraction. Negative powers cannot be converted to minus. See, look at the formula here. This is the nice formula. A to the power minus n, 1 over a to the power n. 5 to the power minus 2. Is this minus 25? No. 5 to the power minus 2, 1 over. Just apply the formula. 1 over 5 squared. So the answer 1 over 25. Remember this formula. Number 6, same idea, but if we have fraction. 2 over 3 all to the power minus 1. Is this minus 3 over 2 or minus 2 over 3? Completely wrong. The correct formula is 2 over 3 to the power minus 1 is equal to 3 over 2. So you invert the whole fraction. There is no minus. If you have 9 to the power minus 1, this is like 1 over 9. So you can bring it down. If you have 8 to the power minus 1 in the denominator, this is like 1 over 8. So it will be 8 over 9, the whole answer. That's correct. But remember, if you have addition and subtraction here, 4 to the power minus 1, you cannot bring it down as you did here. You see 9 to the power minus 1, we can say bring it down, and this 8 to the power minus 1, bring it up. There is one condition. We cannot have minuses and pluses between the numbers. If you have multiplication between the numbers, yes, you can do it. Again, if you have multiplication between the numbers, you can do it. But if you have like this here, 4 to the power minus 1 minus, that's a subtraction, 3 to the power minus 1. You cannot bring this one down. Here you have plus 5 to the power minus 1 plus 6 to the power minus 1. You cannot take it up. We will see the correct solution and method in question number 3 in this video for this one. So here if you add 5 plus 6, 11 over 1, that's not the answer. That's a wrong answer. Now, some correct formulas in the exponents, easy to use when we have multiplication. A times B all squared, yes, we can distribute the power. A squared times B squared. Remember, if you have plus, you cannot do it. If you have minus, you cannot do it. Also this one, A times B all to the power minus 1. Because of the multiplication, it's A to the minus 1 times B to the minus 1. If you have division like this, A over B all squared, you can distribute the power. Same thing for number 4. So this example here. See, we can split. 7 is a number, X is a number, Y cubed is a number. 3 numbers are there. Each one squared, 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 and then the answer is there. Let's see question number 1. I think it's a good idea that you can pause a little and then try it. Maybe 1 minute, maybe half a minute. X minus 3 all squared, and there is a minus, k plus 2 all squared, all divided by 8k squared minus 4k. Simplify the expression. Try to get this simple answer. Okay, did you try? Let's go and see the steps and the answer. First, try to avoid the mistakes and use the correct formula. Look carefully, please, here. K minus 3 squared, we can write perfect square trinomial. K squared minus 6k plus 9. That's the formula. Minus, see the minus, we leave it. Now inside here we have k plus 2, all squared. Remember, k squared, 2ab in the formula, so plus 4k, plus 4 again. Now when you multiply with the minus here, you put minus k squared, you change all the signs. Minus 4k, minus 4, leave the first 3. Then you cancel k squared, and you add minus 6k minus 4k, so that's my 10, minus 10k. 9 minus 4 is plus 5. You take a common factor here, see there's a 5, take a common factor, minus 5, so that we can leave 2k, the coefficient here, positive. If you take minus 5 outside, and we have here plus 5, so what we write here is minus 5. Why? If you multiply back in your mind, multiply minus 5 times minus 1 becomes plus 5. So that's correct. We cannot write here plus. That's another common error. You cannot write here plus. Now, listen here, 8k squared minus 4k. What is common here? It's 4k in both. And we have here 2k minus 1. We can cancel. You see that one? You can cancel the 2k minus 1. The final answer, minus 5 over 4k. Simple answer. Let's see question number 2. Find the value of 8 to the power minus 3 minus 3 to the power minus 1 all to the power minus 1. Remember, if you try to think in this method, 8 to the power minus 1, you write 8, and then minus 3 minus 1, you write 3, 5. That's completely wrong. The method is wrong, the answer is wrong. Try to think of another way. You have to simplify inside the bracket first. You can take a little time, please, here, and try to find the answer. 8 to the minus 1, minus 3. 8 to the minus 1, 1 over 8. I know that. Minus 3 to the minus 1, 1 over 3. Combine the fractions inside the bracket. Then you can invert the fraction at the end. Let's see. 1 over 8, see, that's easy. 1 over 8 minus 1 over 3. See, the LCD, the least common denominator is 24. So 24 divided by 8, 3 up. 24 divided by 3 times 1 is 8. 3, now we have the same denominator. So 3 minus 8 is minus 5. Just invert. See, minus 24 over 5 is the final answer. You cannot simplify it. Let's see question number 3. This is the one I have showed you as an example. You cannot take up and down because we have pluses and minuses. Can you figure out the answer, please? The question says, evaluate the expression. Find the value, one number. 4 to the power minus 1, minus 3 to the power minus 1, over 5 to the power minus 1, plus 6 to the power minus 1. In each place, each location of these numbers, you have to put 1 over 4, 1 over 3, 1 over 5, 1 over 6. Then you add and subtract fractions because we have addition and subtraction. Look here. 1 over 4, you have to start like this. Looks complicated. 1 over 4 minus 1 over 3. And this is 1 over 5 plus 1 over 6. You have to deal with the fractions. So here the LCD is 12. You will find another video on adding fractions and all details. Multiply by 3 up and down, so 3 over 12. Multiply by 4 up and down, so that's minus 4 over 12. I think you know that. 1 over 5, 1 over 6. So the LCD is 30. 6 over 30 plus 5 over 30. When you add, you get 11 over 30. Now you can multiply the first fraction times the reciprocal here. Reciprocal means you invert the denominator, 30 over 11. Divide by whatever, 6, divide by 6, so minus 5 over 22 is the answer. You can use any method you like, actually. Just add the fractions correctly. Now, practice number 1, similar to question number 1. Simplify all these until you get the answer. Also, here we have 5 to the power minus 1, minus 2 to the power minus 2, all to the power minus 3, similar to one of the questions. And this one, practice number 3, similar to question number 3. Try this, please. I think you get the correct answer. You find the correct answer here in one slide. Practice number 1, answer only. Practice number 2, answer only. Practice number 3, answer only. Thank you for watching. I hope I can see you in another video with another topic. Thank you very much.